This is our group video for the WMAT123 on the topic optimization. In this video, I'm going to be talking about the optimization. The optimization used to maximum or minimum point of the function. For example, it can be used to maximizing the cost of building of a house or minimum the cost of building a house. For example, in this function, fx equal x squared plus 4x plus 3 equal 0, you need to find the minimum point or maximum point. You just have two programs to differentiate. The first one is differentiate this function. That is fx equal 2x plus 4, and maybe make it equal 0, and x equal minus 2. And the other step is the first derivative should be equal to 0, after which you will get the value for the variable. So in real life, the optimization can be used to four functions. The first one is maximizing the power, minimizing the power, maximizing the profits, and minimizing the loss. So, for example, like this graph, this is the local maximum point, and this is the local minimum point.
Hello everyone, my name is Cassie, and I'm going to give an example to explain the optimizations.
And here's my example. A woman wants to create a box with an open top by removing the square of equal size from the corners of a sheet of paper, just like this one. And if the shape of the mantle is 2 meters by 2 meters, and we want to find out what is the maximum possible volume of this box. And then we come to this part, and this is the graph for the questions, and the width and height is 2 meters by 2 meters. We gonna to cut off the square, and we get these models like this one. And we want to find out the maximum volumes of this open box, and we get this width and height into x, and this is the base, and then we will hand over to Abhi to do the calculations.
Hey everyone, my name is Abhi. Today I'm going to explain you the further part of the calculations for the solution. To calculate the maximum volume, we are given the dimensions for the box as 2 meters by 2 meters. To calculate the volume of the box, we have this as the formula. Step 1, to calculate the volume, we have the formula. This is length into width into height. That's the formula for the calculating volume of the box. In this, we are not given as the length and not the height. We are just given the dimensions for the square. This is 2 meters by 2 meters. To know the length, the total length for this is 2 meters. So we need to calculate the length for this. So that's why we're taking this part, this part, this part, all of the borders as x. Because as this is a square, we can take x as in all of the parts, because in square all the dimensions are same. So the equation that we get is for the length, that is 2 minus 2x. We have 2x. The reason for 2x is because x is this and this is 2. So we are minusing 2 minus 2x. So these are the two parts. Out of that comes out. That will be same in case of the width, because that's a square. So the width will be the same. 2 minus 2x. And having the height height for the box will be this part. As when we folding the sheets, this side of the box will be the height of that. So the final equation that we get out here is 2 minus 2x brackets 2 minus 2x and all multiplied by x. That's the final equation. To have this, to calculate the maximum volume, we'll have to get the derivative out of this. So for calculating the derivative, we just need to solve the equation in a better way. And after this, we solve the equation in a better way. We get the final equation as 4x minus 8x squared plus 4x cubed. As this is the final equation, the step 3, we have to calculate the derivative after this. We just make this equation a bit more simplified and make it into the derivative. So the answer we get is 4 minus 16x minus 12x squared. We come moving on to the fourth step. for calculating the critical points of the box, we will be keeping that equal to 0. So what we get after that is 4 minus 16x minus 12x squared is equal to 0. Making this more simplified, we will be dividing all of this part by 4 and all of this part by 4. So the next equation that we get is 1 minus 4x plus 3x squared is equal to 0. What I look out here is I got a quadratic equation out here. To solve the quadratic equation, we have two possible things. We can factor that or solve that by the quadratic formula. As this is an easier equation, so probably I'll be factorizing that. After factorizing, what I get is 3x minus 1 and x minus 1 and equal to 0. We'll be keeping both of them equal to 0. So what we get is x is equal to 1 by 3 or x is equal to 1. After this, what we know that the volume of the box. So moving on to the fifth step. The fifth step, we will be just putting all of the values of x as like 0, 1 and 1 by 3. For calculating the derivative, we have two possible outcomes, that is putting the equation as 0 or that the equation gets undefined. But in this case, as we have the equation, that makes no sense that we have the equation as the undefined one. So when we put x is equal to 1, the answer we get is 0. After, at the second part, we put the equation to equal to 1 and the answer we get is 0. So that's not the possible outcome. When we put the equation equal to 1 upon 3, as that is what we got out here. The final answer that we get out here is, after solving the equation, the final equation, we get 16 upon 27 meter cube. And this is the maximum part of that, and this is the minimum. So after this, we come to know that the maximum volume for this box is this one, 16 upon 27 meters cube. That's it. Hence, this was the problem and that's solved. Thank you.